So alkanes এর আমাদের কি কি পড়তে হবে? First of all, we need to study about the homologous series. Now, first of all, we need to study what are alkanes. So alkanes are saturated
carbon-carbon single bond,
saturated hydrocarbons which have carbon-carbon single bond and is linked to the maximum number of hydrogen atoms. It's linked to the maximum number of hydrogen atoms. So that's alkanes. So we also know its general formula, right? Alkenes a general formula key. What is the general formula of alkenes?
CnH2n plus
CnH2n plus 2.
CnH2n plus 2. Achha, very good. Achha. Next is nomenclature. Nomenclature কিন্তু আমরা অনেক দিন পড়ছি, right? Naming compounds. Achha. So nomenclature done, general formula done, nomenclature done. Physical properties. So physical properties are very easy. Normally, what we talk about melting point and boiling point, right? Melting and boiling point. What happens to the melting and boiling point?
it increases.
It increases. Okay, very good. It increases. When does it increase? As the number of carbon atoms increases, right? Melting and boiling point increases as the number of carbon atoms increases. Achha. Next is density. Density ki hoy?
It increases.
It increases as the number of carbon atoms increases. Why? Because as the number of carbon atoms increases, what happens?
chain length increases.
Chain length increases and
Van der Waals forces increases.
Van der Waals forces increases. So what happens to the state? Gas to liquid
And to solid.
to solid. Right? Achha. So melting and boiling point increases, density increases, solubility
Decreases.
solubility decreases. Very good. Solubility decreases as the number of carbon atoms increases. Did I miss out on anything? Let me check.
So viscosity.
Viscosity. Okay, very good. Viscosity. Viscosity. What happens to the viscosity?
As the number of carbon atoms increase, the viscosity increases.
Why does it increase?
Is it like stronger, like Van der Waals forces?
So stronger Van der Waals forces, and since it's become a stronger Van der Waals forces, it's turning from gas to liquid to solid. So it's becoming more thicker, right? And what is viscosity? Viscosity is basically how thick the substance is. So viscosity increases as the number of carbon atoms increases.
Sir, solubility টা একটু আবার বলবেন?
Solubility decrease করবে সবসময় মনে রাখবা এটা হলো solubility in water. Okay, we are talking about water. So water কি type of compound? এখন তো তোমরা জানার কথা. What type of compound is water?
Polar.
Very good. And what type of compound is alkane?
Non-polar.
Non-polar.
Non-polar molecules cannot form hydrogen
hydrogen
bonds with the water molecule. এর জন্যই they are not soluble. So write down the explanation. Let's talk about melting and boiling point. So melting and boiling point depends on what?
The number of carbon atoms.
The number of
Intermolecular forces.
So melting and boiling point depends on the strength of intermolecular forces. Intermolecular forces. So এখানে specifically van der Waals forces. Why van der Waals forces? Because alkanes are or what type of compound or what type of molecule?
Non-polar.
Non-polar. So melting and boiling point depends on the van der Waals forces. এখন van der Waals forces depends on what? আমি chapter 4 এ পড়াইছিলাম if you remember. Van der Waals forces depends on the number of electrons and the number of contact points. So number of electrons key as the number of carbon atom increases, the number of electrons increases, strength of van der Waals forces becomes stronger. Strength of van der Waals forces are stronger. Next, let's come to number of contact points. So number of contact points, when does this come into play? When the number of carbon atoms is equal. The number of contact points, when the number of carbon atoms are equal or same, or actually structural isomers. Structural isomers. Okay, let's take number of contact points. Number of contact points. Actually, N-pentane. N-pentane is basically CH3, CH2, 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 CH3. মানে এটা actually unbranched যেটা। তারপর isopentane, when they have one branch. So what can be an isomer of pentane?
2-methyl butane.
2-methyl butane, okay. So CH3, C, CH3, H, CH3, CH2, CH3. So this is isopentane, or আমরা যেটা শিখছি সেটা হলো 2-methyl pentane. And then there's neopentane. Neopentane means there will be 2 branches. So what can be the name of this compound?
Sir, 2-methyl butane হবে না?
Neopentane কি জিনিস?
Dimethyl propane.
Dimethyl propane, yes. Dimethyl propane. So CH3, CH2, CH3, CH3, CH3. So এটার নাম হবে 2,2 dimethyl propane. 2-methyl propane. So surface area সবচেয়ে বেশি কার? Who has the largest surface area?
Pentane.
Neo.
Pentane.
Oh.
Who has the smallest surface area?
Neopentane.
Neopentane.
Neopentane or 2,2-dimethylpropane, right? So surface area decreases from pentane, which is more than 2-methylbutane, which is more than 2,2-dimethylpropane. So surface area কম মানে কি?
Contact points কম.
Number of contact points is less. Less number of contact points. So less number of contact points means
Weaker van der Waals forces?
weaker van der Waals forces. So that's all about physical properties of alkanes. Acha, so আমি তোমাদেরকে last classে গোলাম আবরার what are the steps of substitution reaction?
First step হচ্ছে initiation step.
Initiation step, very good.
হ্যাঁ।
Initiation
পরে-
step.
হ্যাঁ, পরে propagation and then
Propagation.
termination.
And then termination. Propagation step. And then termination step.
Termination.
So we are starting with the number one property, which is substitution reaction. More precisely, what do we call this?
Free radical substitution.
Free radical substitution. Free radical substitution. So what is the initiation step?
So the covalent bond between the halogen is broken in the presence of UV line, UV
Very good. So first of
by
all,
homolytic fission.
by homolytic fission. Very good. So first step, what happens is we have a chlorine, অথবা chlorine না. Let's just take XX. কারণ it could be any halogen. X and X. And they have a shared pair of electron between them. So when you're giving UV light, when you're giving UV light, what is happening? So there is a single transfer. So this is going to be a one-way arrow. Okay, one-way arrow because one electron is going. So it's going to be a single-headed arrow. Single-headed arrow. And it forms a free radical. Free radical. It's both the same. Since we are using a dot and cross diagram, I am drawing it separately, but it's the same thing. We get two free radicals. Then propagation. Propagation means once this reaction has been initiated by whom? By UV light forming free radical. Then what happens? That way. So if we take a methane, and we have a free radical. This chlorine will attract this hydrogen. This chlorine will attract this hydrogen and it will initiate or this will cause this carbon hydrogen bond to break down. Forming what?
HCl.
Forming a carbon with a hydrogen, with a hydrogen, with a hydrogen, and a free radical plus HCl. Right? আচ্ছা আমি একটু ভুল করেছি ভুলটা হলো যে We started off with X, so this should also be X. This should also be X. Acha. Next, this will be our starting material. So CH, what do we call this compound? Methyl free radical. This is known as methyl free radical. So this methyl free radical again reacts with another chlorine. এখন কিন্তু এটা কিন্তু once it has been initiated, এটা কিন্তু কাজ শেষ. Once it has initiated, that's it. Propagation is how it's proceeding. So here we had methane and we had a free radical, then we got a methyl free radical and a HX molecule. Then this methyl free radical will again react with what?
X.
A halogen molecule. It will again react with a halogen molecule. And then do what? A methyl will then do what? It's going to attract this hydrogen, right? Sorry, hydrogen. It will attract this X or halogen. আবার এখানে কি হবে? What will happen? Again, there's going to be a homolytic fission. And then it's going to form a CH, H, H with the X plus there's going to be a X free radical. So this will keep on continuing until how long will this keep on continuing?
Sir, until all the hydrogens have been replaced by the X.
Exactly, until all the hydrogen has been replaced by X. So this is our starting reactant now. So we have a CH, H, H, and an X, right? And then we have this free radical which was generated. This X will then attack a hydrogen, not an X. It's going to attack an hydrogen, the next hydrogen. And then do what? It's going to then form a free radical plus HX. So third step,
Termination.
termination step. So termination step is basically you join all the free radicals. তাহলে কি কি হতে পারে? So একটা chlorine free radical ছিল and it forms Cl2. তোমার chlorine আর CH3 free radical ছিল, you can form a CH3Cl. And then you have a CH3 free radical with a CH3 free radical, and it can form what? It can form a C2H6. Right? Or you can also have a CH2Cl free radical plus with another
X ধরেছিলাম তো।
আচ্ছা হ্যাঁ ঠিক আছে, X ধরেছিলাম, তাহলে X thank you. So XX will become X2, X and CH3 will become CH3X, CH3, C2H6, CH2X, CH2X will form C2H4X2. So next thing we need to know is which halogen will give the fastest reaction. With an alkane. Number one, with fluorine. Reacts vigorously. Even in the dark. At RTP. It all with methane. It's just an example. With ethane same hobe, with propane same hobe, progressively ja ja ache. With chlorine, with bromine. No reaction unless the reactants are heated or exposed to UV light. No reaction at all. So what is the reason behind this? So methane, CH4 plus fluorine, gives us CH3F plus HF. Can somebody tell me the bond energy for CH? CH, data booklet. 410, I guess.
413.
413. So
413.
413 into 4 is how much?
So 1652.
Yes, sir.
And what is the bond energy for fluorine?
So 142.
142 into 1 is
So
one-
not sure.
not sure. Anybody, can you please tell me, find out bond energy?
159.
159. Achha. It's 159. So you have 159. So in total, what energy do you have?
1811
1811.
11.
Okay, great. So এখানে আমরা CH is 413 into 3 because one of them has been substituted by CF. This is X into 1 plus. What is HF? What is the bond energy for HF?
562.
562. So 413 into 3 কত?
So 1239.
1239. And what is this? Is X and this is 562.
62.
So 1239 plus 562 কত?
1801.
Sorry?
1801.
180. Okay. So del H. আচ্ছা এটা আমরা CF, can somebody tell me the value of CF?
$453.
453. So now if you add them, how much is the total value?
So 2254.
So 1811 minus 2254.
So minus 443.
Minus 443.
So if you go from fluorine to chlorine to bromine to iodine, so you'll see that your enthalpy decreases, and it becomes less exothermic. It becomes less exothermic. So since it becomes less exothermic, reactivity decreases. So what is the value for So fluorine is 159. What is chlorine?
242.
242. What is bromine?
193.
Iodine?
151.
1.
51.
So you can write down as the enthalpy change of the reaction decreases from fluorine to chlorine to bromine to iodine. Therefore, reactivity also decreases. So if we compare complete and incomplete combustion for the same type of organic compound, if you have complete combustion, the energy release is very high. If you have incomplete combustion, the amount of energy released is also low. So if you have incomplete combustion, there's two problems. One is you will have less energy, and the second problem is you will have it's going to cause pollution to the environment. Alkenes আমাদের যেটা এখন বাকি আছে যেটা হলো cracking. So why do we do cracking? We already learned it, right? Samir Buddha, why do we do cracking?
Sir, we crack to we crack মানে ছোট করার জন্য to make bigger hydrocarbons into smaller hydrocarbons.
To get alkenes and smaller hydrocarbons.
হ্যাঁ,
Yes, but why do we do it?
Because more fuel efficient. The smaller chains are more fuel efficient.
More in demand.
More in demand, exactly. So cracking is basically breaking down of long chain hydrocarbons into smaller chain hydrocarbons. Breaking down of long chain hydrocarbons into smaller chain hydrocarbons. This is done because small chain hydrocarbon is more in demand, less in supply. Long chain hydrocarbon is more in supply, less in demand. Therefore, long chain hydrocarbons are broken down into smaller chain hydrocarbons to meet the demand and to prevent any wastage. So next is types of cracking. Types of cracking. Number one is thermal cracking. Number two is catalytic cracking. Catalytic cracking. Actually, we use heat, আরেকটাতে we use catalyst. তাহলে thermal cracking এ আমাদের thermal cracking. Use of heat to break long chain hydrocarbons into smaller chain hydrocarbon. Condition kiki. What are the condition? Very, very important conditions.
High temperature.
Temperature is 800 degrees centigrade. Pressure.
High pressure.
Moderate pressure. Our condition. মানে স্পেশাল কন্ডিশন হলো এটা অ্যাকচুয়ালি কন্ডিশন না লিখে এটাকে কি জানি বলে এটাকে কন্ডিশনই দেখো আর স্পেশাল কন্ডিশন হলো no in the absence of air কারণ if you have air what will happen
Combustion.
then it will be converted to carbon dioxide and water because it's going to undergo combustion, but we don't want that. So it has to be in the absence of air. Or presence of steam. Presence of steam.
Sir, do we need to memorize values for temperature and pressure?
Yeah. Yeah. This is something you need to memorize. Kichu korar nei. So thermal cracking conditions, temperature, pressure, condition, absence of air, presence of steam. So at the example, CH3, CH2, 10, CH3. So it's a 12 carbon compound. Dodecane. We use the conditions. What are the conditions? 800 degrees centigrade, moderate pressure, absence of oxygen, presence of steam. We get CH3, CH2, 4 CH3 plus 3 CH2, CH2. So this is hexane and this is ethene. So hexane is used as fuel. Ethene is used as a starting reactant in the plastic industry. So polyethylene. Polyethylene means that we polymerize ethylene. So we break it down, we break the compounds into such fractions so that none of it is wasted. And why are we so concerned with this? Because non-renewable source of energy. Once it's been used up, you cannot reform it.
Sir, what's the name of the catalyst?
Zeolite.
Sir, aluminium or ki jani catalyst chilo na?
So next class we'll be studying alkenes. তোমরা যদি alkenes এর reactions গুলো না পড়ো তোমরা কিন্তু বুঝবা না।